Or is inverse functions. This question says the cosine of theta is equal to radical 3 over 2. Another way you could ask this question is just to say the cosine, the inverse cosine of radical 3 over 2. It's asking for the same thing, which is what is that angle measure. So one thing you could do, sine and cosine both deal with that palm of your hand. So as we look at it, the only thing that involves a radical 3 as far as those special reference triangles, if you've memorized those, it's in that ratio of 1 radical 3 to 2. Cosine is adjacent over hypotenuse. So the adjacent side over the hypotenuse, that's going to mean that your answer is 30 degrees. Now the other thing that you can do is you could look at your hand, pointer, middle, ring, pinky. You could look at the palm of your hand, and it's in the order of, remember, cosine comma sine. So if you want the cosine to be radical 3, here you have your 3 fingers. So you want to fold in this finger right here, and that happens to be 30 degrees. So it's going to be 30 degrees. That's the way that you can look at it in that format, as well as just looking at your finger. Going to get radical 3 over 2 for cosine, I have to fold in my ring finger, which is going to be 30 degrees. Now I do want to point out, this does say put it in degree measure, but 30 degrees, if you needed that in terms of radian measure or with the pi, we have this unit multiplier where 180 degrees is the same thing as pi radian. So if you reduce, 30 goes into 180 6 times. So it's the same thing as pi over 6 radians, and 180 divided by 6 is 30. So if you had to put it in radian mode or radian measure, that's what it would be in radian measure. Otherwise, we can just go back over here, type it in as 30 degrees, and look at the next example. Now the next example is asking for the tangent. So we are going to want to flip our hand if we are doing the hand trick. So the tangent of theta is equal to radical 3 over 3. So we have to think about this a little bit differently. You have to think of what is it when I did not rationalize the denominator, because remember, tangent says that I'm looking at the back of my hand. There's the pinky, ring finger, middle finger, pointer finger, and then you have your thumb sticking down so you can see your tangent. And the only thing you are working with tangent, we don't have anything on the back of our hand except for that word tangent. It's not like we have that 2 that's in the palm of our hand for that denominator of the fraction. So in tangent, what we are looking at is what fingers over what fingers. Now this does happen to be a rationalized denominator because your fingers are radicals, remember that. So what you could do, if you don't remember what radical 3 over 3 is as far as tangent and the angle that has a tangent of radical 3 over 3, what we can do is you take this and rationalize the numerator. I wanted a different color for that. So if I rationalize the numerator, you're just going to take numerator and denominator by that radical value that's in the numerator. That's going to give you 3 because radical 3 times radical 3 is 3. The denominator is 3 radical 3. So the 3's cancel and you're left with 1 over radical 3. That means radical 1 over radical 3. So when we have our hand flipped, what we want is we want 1 finger over 3 fingers. So that means what I'm folding down is I am folding down my ring finger. Then you flip your hand back up, and if you flip your hand back up with your ring finger being folded in, the ring finger is what's folded, and you have 0, that is making reference to 30 degrees. So 30 degrees, the tangent of 30 degrees is radical 3 over 3. The way that I also think of it is tangent's going to be sine over cosine. There was one other way that I have not mentioned yet to memorize sine, cosine, tangent of 35, 45, and 60-degree angles. And the way that you can do that is you can put those in increasing angle measure, 30, 45, 60, on a calculator, which you don't get to use. The functions appear as sine, cosine, and tangent in that order. So what you can do is it's going to be radical 1, which is 1, radical 2, and radical 3, all over 2. Then you're going to reverse it, radical 3, radical 2, radical 1, which is just 1, all over 2. And then tangent is sine over cosine, so for 30 degrees, you're going to have 1/2 divided by radical 3 over 2, sine over cosine. You keep, change, flip. The 2's cancel, and you get 1 over radical 3. Now, if you were to rationalize that denominator, you're going to get radical 3 over 3. So 30 degrees, you're 3 happy. You're going to have 3 occur in 3 spots when it's radical 3. If you look at 45 degrees, you have radical 2 over 2 divided by radical 2 over 2, which is 1. And then for 60 degrees, if you keep, change, and flip, you're just going to end up with radical 3. So you think 3 is half of 60, so it's only going to occur once. You're just going to have radical 3. But the 30 degrees, you're 3 happy, so 30 degrees, radical 3 over 3, it occurs 3 times. So the tangent for this does happen to be 30 degrees, and they want it in 30 degrees. I'm going to type that in, move it to the next screen, and pause it since the whistle's going off again. I don't know if you can hear it or not, but here we go. Okay, so for the next one, I'm just going to, I'll leave the chart up there for a second. If you look at that chart, if maybe that's the way you choose to do it, you could do the reference triangles. You could look at the chart where you create that, just put 1, radical 2, radical 3, all over 2, reverse the order, and then take the sine divided by the cosine value. The cosine of radical 2 over 2, if you look right here in your chart, that's going to have a value of 45 degrees. If not, you look at your fingers, pointer, middle, ring, pinky. You have the 2, and you want radical 2 for cosine. Cosine's the top. You're going to fold in this middle finger, which when you look at it, 0, 30, 45. Your answer is 45 degrees. Just as a refresher again, 45 degrees, there is pi radians in 180 degrees. And if you reduce, 45 goes into 184 times. It would be the same thing as pi over 4 radians if you had to have your answer in terms of radian mode. So this is going to have a value of 45 degrees. Tangent of what angle is radical 3. Once again, you want to be careful with that when you are looking at this with your hand trick. We see that it's going to be 60 degrees. If you're dealing with special triangles, 60 degrees, you can change that over into radian mode if you want. Rationalized form, do not round. So if we look at it, a tangent, what angle has a tangent whose value is radical 3? So you're going to be looking at the back of your hand. That's a bad pinky, probably one of the better ones though, skinny instead of fat. There's your pinky, your ring finger, your middle finger, your pointer finger, and then you have your thumb. And we're looking at the back of our hand because we are referring to tangent, and we know that radical 3 is the same thing as radical 3 over radical 1, or 1. So I am dealing with radicals, which is your fingers, so you have 3 over 1. So you're going to fold in this pointer finger. Now don't forget, you got to go backwards with your angle measure, or flip your hand back to the flip your hand back over so you can see the palm of your hand so that your thumb is up, and you fold it in your pointer finger. You have 0, 30, 45, and that is 60 degrees. Otherwise, remember the pinky is 0. It's the, besides, yeah, pinky is going to be 0. I was going to try to tell you something, but I don't think that'll work. 35, 30, 45, 60 degrees. So the answer for this one does happen to be 60 degrees. Oh, shit. 60. Oh, and I even told you you needed it in terms of radians. Or I looked at it and it says simplify it, and I've been changing them to radians for you, and the one that I didn't change, then they asked for it that way. So you have 60 degrees and pi radians over 180 degrees. 60 goes into 183 times. So your answer is pi over 3. And I put it in degree measure. Be careful of that on your test with your college professor to make sure you do get it correct. Oh, I can't believe I did that. Okay, this one does ask for you to put it in terms of, I'm just going to go through some of these real quickly here so I can see what other additional ones up a level might. Okay, here's one. Where is the tangent equal to 1 at? That's going to be when you have the same value for sine and cosine, and that occurs at 45 degrees. This one does say write your answer. Oh, and I probably should have kept that up there for you real quick. Write your answer. I'm going to get this one correct. Write your answer in radians. So it's at 45 degrees. There's 4 of them in 180 degrees. That's going to tell you what your denominator is. But if not, do that unit multiplier. Pi radians is the same thing as 180 degrees. And 45 goes into 180 4 times. So now I'm going to type it in correctly, and I should have noticed that on the last one. So we have pi over 4. Where is sine equal to radical 3 over 2? I don't care which way you do it. Your hand is always with you. Sine is the bottom, so you want 3 fingers over 2, radical 3 over 2. So to get those 3 fingers, you have to fold in your ring finger, which is 60 degrees. There are 3 measures of 60 degrees in 180, so therefore it's going to be pi over 3. How many appear in 180 degrees? If not, use that unit multiplier. 60 goes into 180 3 times, and you end up with pi over 3 radians. So let me go here. It's going to be pi over 3. Okay, looking at this one, I was just going to skip over these because I was like, oh, you don't get your calculator. But it does say as an integer or as a decimal, rounded to the nearest hundredth. This is going to be really close to a 45-degree angle, because if you look at the sine of 45 degrees, the sine of 45 degrees is going to be radical 2 over 2. And the decimal value of that is 0.707106. So I would say a 45-degree angle, but it says rounded to the nearest hundredth. And I think if you type that in on your calculator, which you don't get, so I don't think they're probably going to give you this type of question. It's a good thing to know that radical 2 over 2 is about 0.707 though. But anyway, I think if you round it, you get to the nearest hundredth, you get that. We'll see if I'm wrong or not. Why is it 0.78? Oh, because it's okay, Austin, here's where I messed up once again because I did not read it carefully. And that's what you got to be careful of. I guess a lesson learned. for you through me by making that mistake. Right here it says, this is what the question was. Theta is an acute angle. Find the value of theta in radians. And I was talking about 45 degrees because I was saying that 0.7 is approximately radical 2 over 2. So I was looking in degree measure. You would have to use your calculator for this one because you would need it in radian mode. So you are not taking the inverse sine of radical 2 over 2. In radian mode, they are taking the inverse sine of the value of 0.7. And if you do type that in on your calculator, you do get 0.77539. So that's where they get this value of 0.78, which would be correct. So that was my bad, my mistake. All right, so we go back to this particular problem. They're saying, what is the tangent that has a value of radical 3 over 3? Well, they do want the value, hopefully we can remember this, in radian mode. So radical 3 over 3, remember I said the happy threes? There's 3 of them when you talk about 30 degrees because that's radical 3 over 3. So 30 degrees, when you talk about radian mode, you have 180 degrees in pi radians. They wanted that one as a decimal. The previous one, when they said in a decimal, when it said that it would be pi over 4, but since they wanted it as a decimal, you're going to have to take 3 point. I'll back up and clarify that here in just a second. So, because they wanted it in that decimal, so you're still like, why isn't it 45 degrees? Why isn't that pi over 4? And that wasn't the answer. So anyway, 30 goes into 180 6 times. So your answer for this one would be pi over 6. Now for the previous problem where I messed up, first I didn't put it in radian measure. Second of all, I didn't put it as an integer. I just glanced and I saw this part and it said something about an integer or a decimal rounded to those hundredths place values. So that's what I was thinking. In radian measure, what you would do is now to convert that over, you're going to let pi be 3. Here's what your answer was. This inverse sine of 0.7. And I said that's really close to 45 degrees because 0.707 is a value that's really close to radical 2 over 2. So the sine, the angle whose sine is radical 2 over 2 is going to be 45 degrees. Well, they wanted it in radian measure, so what I should have done is said 45 degrees, pi radians. There's 180 degrees in pi radians. 45 goes into 184 times. So then I should have said in radian measure that it's pi over 4. But they wanted it in decimal. So then when you change it into decimal, you're going to take 3.14 and you're going to divide by 4. And when you take 3.14 and you divide by 4, that's going to give you close to 3/4. So that's what gave you the point. I don't remember what they said now. That's really close to 3/4. So it's 0.75, or that's where they got the decimal value on the previous problem. So I apologize for that. This one, they do want in radical format. They didn't say in a decimal format. So that is going to be this pi over 6. I hope I clarified that for you. I apologize for making a mistake there. Oh, here's another one that we can look at. Okay, so I skipped over that last one that you saw maybe at the, I paused it because I did have a message here on my phone. They had to call the unit for a player here. That's why the whistle was going off for one of the players at the volleyball tournament. So I was looking at that, but and then I calculated the last problem there. If you look at it, you're going to get a value that's around 72. If you calculate it on your calculator, you get 1.266. It's going to be something that you need your calculator for. I apologize, but some of these you just need your calculator for, and that was one of them. So let me go through a few more here and see if I can't find any other examples that might be helpful to you. Okay, I think I'm going to wrap it up in this one and go to a different one for you, because what I'm running into is a whole bunch that are running into this. And you just have to, once again, make sure your calculator is in the correct mode. So for this one, they do want it in terms of degrees. So you would just have to find the inverse sine of 0.2 and calculate that. And the answer to that is going to be an 11.54 degree angle measure. And that's just something you're going to have to use on your calculator. So I don't know where else to help you. The only thing I can think of when I look at this one right here is sometimes when you're giving an angle, you can give multiple values. So as you look at it, if you have a negative and they're only wanting one value. So here's what you need to remember as well. When you're dealing with sine and tangent, remember in your 4 quadrants, all students take calculus. So to get sine and cosine so that you can encompass the smallest angles possible and still take care of positive and negative angles, sine and cosine are going to range between 90 and negative 90 degrees. So if you have a negative one that they are asking you for an example, if they say the sine of theta is equal to negative radical 2 over 2, to get to that negative angle measure, we know that it's negative, sine is negative in the 3rd and the 4th quadrant. What they're wanting is the smallest angle measures possible, so your answer would be negative 45 degrees. It's going to range, your answer would range from 90 to negative 90 degrees. Cosine, on the other hand, all students take calculus. You can't range from 90 to negative 90 because cosine is positive in that 4th quadrant. So there's where your angles are going to range from 0 to 180 degrees when you're making reference to those particular angles. So the cosine, what angle is equal to negative radical 2 over 2? That's going to give you a 45 degree reference angle in the 2nd quadrant. So you would take 180 minus that 45 degrees, and you're at 135 degrees, and that's what your answer would be. Now, if it's positive radical 2 over 2, you're dealing with the 1st quadrant, and your answer would just be 45 degrees. So that's the last thing I want to throw in that probably deals with this and what you are looking for. I'll continue going through some of these. I'm going to save it and post it, but then I also want to look at the law of sines and cosines for you.